Time to get tricky with it. Our next algebraic limit method. So we're getting tricky with it. It will really help you. It will save you tons of time if you follow the directions and memorize these. They're not too hard. Make little flashcards. It will make it so much easier for you in the long run. Alright, so we don't have tangent of 4x over x, but what we could do is instead write tangent of 4x over x if I multiply the bottom by 4. I know that limit. Okay, if I'm going to multiply the denominator by 4, I have to also multiply the numerator by 4. So the limit as x approaches 0 is 1 times 4, or just 4. This one's kind of close to the secant one. The cosine one. So let's divide everything by secant of 2 theta. Okay, so I'm going to get, there we go, cosine of, well, not yet, I guess. I should change that. There we go. Secant of 2 theta divided by secant of 2 theta, 1 minus cosine of 2 theta, all over theta. That's close to being what I want it to be. So if I multiply this by 2, this by 2, alright, I know that limit 0, 0 times 2, still 0. Let's try the next one. I have tangent, let's just rewrite this maybe. Limit as theta approaches 0, tangent theta over theta, oh, I know what that is, times cosine theta, I know what that one is as well. Alright, so tangent theta over theta, we know that one is 1 as the limit approaches 0. 1 times cosine of 0 is 1. Our limit is equal to 1. Alright, this is where the fun starts. Because you memorized all of those things in the top, right? So you know it's simply 5 over 7. Yippee. Alright, this one not too hard once you rewrite it. Limit as t approaches 0. I'm going to write it as sine of 2t times sine of 2t over, alright, I'm going to do t times t, and I'm going to put the 3 over here. Now, if I make this a 2, and I make this a 2, I'm multiplied in the denominator by 4, so I'm going to have to multiply in the numerator by 4. Now, when we go to do the limit, this is 1, this is 1, this is 4/3, so our limit is equal to 4/3. Kind of a neat problem. Alright, this one, let's see, what can I do? There's a lot of things to do with this. I'll take my time, get a little smaller pen here. Let's start about pulling a negative out in the front, because I don't want to have that 1 minus tangent up there. Alright, well, I see a sine and cosine in the bottom, so maybe I should turn the top into sine and cosine. And actually, instead of writing 1, I'm just going to write cosine over cosine so I can combine them. Alright, so keeping and simplifying this, I get sine x minus cosine x over cosine x all over sine x minus cosine x. Okay, if I multiply by 1 over sine x minus cosine x on the top and the bottom, come on, sine x minus cosine x, those cancel out, so I'm left with negative 1 over cosine x, which is negative secant of x, so the limit as x approaches pi over 4 secant of x. Instead of being square root of 2 over 2, it's a reciprocal of that, which when you simplify it ends up being negative square root of 2. Not a bad problem. This one I bet we'll do some factoring. Alright, so I could take out a 2 in the top and the bottom and then cancel them out. So if I do that, I get 6 cosine squared x plus cosine x minus 2 all over 2 cosine x minus 1. My bet is that I can factor the top into 2 cosine x minus 1 times something. So I'm guessing that's going to have to be 3 cosine x plus 2. Does that work? Looks like it does. All right. So here, these cancel out. Beautiful. Now what's the limit as x approaches pi over 3? Cosine of 1/3 pi. That would be 1/2. 3 times 1/2, 3 halves plus 2. So let's see, 3 halves plus 4 halves is 7 halves, or 3.5, either way. All right. So that one's not too bad if you memorize things and you know how to manipulate trig functions. General cleverness. That's always fun, right? This one you can only know by doing and practicing, and you'll come up with things all on your own. It'll be great. All right. So this one, if we put in 0, cosine of 0 is 1. We can't have a 0 in the denominator, so we have to do other things. In this case, we can multiply the top and the bottom by the conjugate. Yeah, let's make it look worse before it gets better. That usually helps in calculus. So we have 5x squared times 1 plus cosine of x all over 1 minus cosine or squared of x. 1 minus cosine squared. Using our Pythagorean identities, we know that's sine squared. So if I have x squared over sine squared, okay, times, and I still have that 5 times 1 plus cosine x. Take the limit as x approaches 0. Well, that right there is going to give us 1. Cosine of 0 is 1. So I have 1 times 5 times 2 gives us an answer of 10. General cleverness here. Factor. Factor will help. Limit as u approaches 5 from the right-hand side. You can factor out a negative, and it might make this easier to factor, and then you just put it back in. Okay? Either way, it's going to end up being 5 minus u, or negative u plus 5, however you want to think about it. And then 1 plus u over 5 minus u. Okay, absolute value. So this part, remember that we've already used those. That means that we're going to have the opposite here, the piecewise function. So if we plug in 5 to the right side of 5, okay, something like 6, 7, we're going to end up with a negative, okay, negative 1 times 1 plus 5, which is 6. So we end up with negative 6. This one, I'm going to give you a hint. I would like you to factor. Great idea, I'm telling you. Factor, okay? And then write your answer in your whisk. Number 9, our last method that could be helpful would be a limit sandwich. This we're not going to use very often, but it does come in handy every once in a while. If you have that sandwich, that function that's stuck between two other functions, and the two outside functions, the two pieces of bread, both approach the same finite value, then that inside function does that too. So to use it, the inequality must be shown. I'm not sure if your papers say this, so if they don't, just change it, maybe that part. Okay, something printed wrong on my sheet, so I'm not sure if yours is also the same. Okay, find the limit. So the inequality must be shown. We've got that. The limits of the two functions must be shown. So what is the limit as x approaches 1 of ln of x plus x squared? Well, ln of 1 is 0. X squared at 1 is 1. All right. The limit as x approaches 1 for e to the x minus 1. It's going to be e to the 0, which in turn is just 1. Okay, we did that. And then a concluding statement. So since these two are true, by the squeeze theorem or the sandwich theorem, limit as x approaches 1 of j of x equals 1. The end. Okay. If you take a look at this last sheet, there's a summary of everything we've talked about for this whole section. Okay, my favorite part is number 12, limits are fun, because you know they are. Okay, have a great day.